Hello everyone and welcome to another video in our series about Compose Navigation 3. In this one, we will take a look at how we can use view models with Navigation 3, how we can scope them to our entries, and after that, because there are two components to making view models work, we will do a deep dive into both of them, so you will understand both how to use them and their inner workings. So I will do a deep dive into how save state works and how view models are built on top of that. This will be this video will be split into two parts. So if you just care about how to enable view models and you want to use them with some dependency injection library, then it will be a quick one for you. But for the rest of you that want to stay for the deep dive and listen, then we will do deep dive and you will be able to understand everything under the hood. So let's start. First, what we need to do is we need to add a lifecycle view model for navigation 3 dependency. That is the dependency, and this is the version. Now we are able to start, but before that, let's just explain why we want to do this. View models are scoped to the nearest view model store owner, and in the case that we have right now, when we did not do anything, we're just continuing where we left off. That will be either our app activity on Android, or it would be default architecture components provider. So either one, and I will show you where it is implemented. So for the iOS, for example, it will not be the activity, but it would be Compose UI View Controller. And if we go into its implementation, then you will see just a second that this will be the implementation of ViewModel Store Owner's architecture component store owner. It's a default one that's used, and as you can see, it's a lifecycle owner, ViewModel Store owner, SaveableStateRegistry owner. It has its own lifecycle, ViewModel Store, etc., etc., etc. So we don't want, and this single one would be used for every navigation entry or screen that we have in our app. And we, of course, don't want that. We don't want to bloat resources, to waste resources. We don't want everything to be a singleton in our app. We want everything scoped nicely, so we do lazy initialization and we do cleanup. We don't want to run into some weird side effects or behaviors because of preserved state, etc. But you already know all of that probably. So that is why we want to do this, and now we will actually see how. And after that, we will see how all of that works under the hood. Let's start from our problem statement, and as I mentioned, the view models are scoped to the nearest ViewModel store owner. So inside of our entry, let's see what we'll get. Local ViewModel store owner current, and we will print it out. If we run the app, and if we take a look at the logs, then just a second, you cannot see it from me, but you can see that it is app activity. Everything is scoped to our app activity. We don't want that. We want everything to be scoped per entry. Let's solve our problem. How we do that in navigation 3 is we use decorators. We have two decorators for this one. Those are, the first one is to enable the whole saving state mechanism. And the other one is to enable our entries to be store owners and to scope view models to them. And now, if we run the app with this one, we will see that we no longer have app activity as our view model store owner. As you can see, it is child view model store owner for navigation entry. We scoped it to our onboarding one. And keep in mind that you cannot have these mixed up. If you run the app like this, it will actually crash because view models are built on top of saving state mechanism, and you cannot have this. Yes, it is crashing, and if we take a look where and why, it will say that ViewModel StoreNavEntryDecorator requires adding of the saved state NavEntryDecorator to ensure support for saved state handles, which view models rely on. So you cannot mix these two. The ordering matters, same as compose modifiers. If we run this again, everything is fine. We don't get a crash. We just get, again, our ViewModel store owner that we have here. And we will just demonstrate how to create a view model. We will have some view model, and then you have to use you have to create it like this, because otherwise it will crash on iOS. I will show that later. But for now, let's see. We will run the app and see that it runs fine. And we can even add some state just to see. And we will consume a view model state, collect as state equals by and we will now collect state. Yeah, as you can see, it works fine. It also works fine on the iOS. I will just stop the Android one and we will see the iOS. Okay, so here we have it. That took a bit longer, but you can see that the app runs on the iOS and that we have our state printed as 1. If that is all that you care about, then see you in the next one, where we will be covering deep links for navigation 3. If you would like to learn more, then stay, because from now on we will do a deep dive into these two decorators, and we will see how they work, what they enable, and how they build on top of each other. So if you're going now, see you, and the rest of us, let's do a deep dive. Let's first see what even is NavEntryDecorator. If we take a look, decorator is a very simple thing. Implementation of the decorator pattern. We have decorate that will be called for each nav entry or every screen that we have in our navigation, and it will wrap it and decorate it with additional behaviors or additional functionality. And we have on pop, when the destination is popped from the navigation stack and where you would typically do cleanup. Let's take a look at SaveableStateHolderDecorator. As you can see down there in the implementation. The implementation is very simple. It decorates each entry and enables it to save state. We will see how in just a minute. And it removes the state when the nav entry is popped from the backstack. As you can see, everything is delegated to this SaveableStateHolder, which that is remembered. And let's see how that looks like and what is it all about. First of all, SaveableStateHolder, that is a central point and the aggregate of all saved states for the whole navigation tree for every entry in our navigation. This is where the states are being coordinated. Each navigation entry, each screen, each composable, however, handles saving and restoring state with the SaveableStateRegistry, and each will have its own registry, but SaveableStateHolder is the central hub for all these different registries, and it will create new ones and remove the old ones that are no longer needed. As you can see, it's remember savable, so it survives process deaths and configuration changes, of course, but most importantly, it survives process deaths. And that's how the state of all composables or nav entry screens are being preserved. it has its own custom saver implementation. And the saver is just a bridge between Compose world and bundle that you get from the activity in onCreate. Let's take a closer look at the implementation. So we have a couple of things here. First of all, it's saved states. Saved states are all states for entries that are not currently visible, so they are not composed, but have their states saved. And then we have registries, as we said. Each navigation entry will have a registry associated to it, and those registries here are for all visible or currently composed navigation entries or screens. And then let's see the part that is interesting in this decorator. It is this composable functions that will wrap every single composable screen that we have. First of all, you can see that it is using reusable content. That's just for the recycling of slots inside of a composition tree, so no destroying or recreations of slots overhead. It will just reuse the same slot for the key. Same as the recycler view will recycle the viewports that it has and will not destroy and create new ones. And here it is creating the registry for our navigation entry for our key. First, it will check if what we are giving it can be saved, as the error message here says. If it cannot be saved, what typically can be saved is what can be put in Android bundles, which are primitive types. And we will take a look at this wrapper soon. Let's just finish with the composable. Here we have composition local providers. We see that registry is provided for both local savable state registry and local saved state registry owner. So the first one is for the Compose world, and the second one is for Android X world, so outside of Compose. It is lifecycle aware, Compose lifecycle aware. It is using the disposable effect, which has on dispose, and first it checks if the key is valid. It restores the state, restores the state if it is when it enters the screen. As we said, saved states are for the screens that are not composed, and when this disposable effect block is called, that means that the composable is composed. So it will remove it from saved states, and it will add above created registry to registries that we said are for active or composed screens or navigation entries, composables, whatever. When it is leaving composition, on dispose will be called, that this is normal disposable effect behavior, and what is being done here, the current registry is being removed from the active registries and is being saved or put into saved states. So it goes from active to inactive, but the state is preserved. And what is left is to cover the other two methods that are important. So save all, as you can see, it takes all saved states and all active registries and saves them into saved state. So typically when the system is, when the process is dying and recreating, then we want to save all. And there is also remove state. It is removing state for a single state for a given key, typically when the individual screens or entries are being popped from the backstack. Save to is just method used here for saving the state registry. You may have noticed that all saved states are a list of any, so it is not just any, it is a list of any, and that is due to how SaveableStateRegistry works. We'll take a look at that now before we take a look at this wrapper here. But basically multiple states or values for the states can be provided for a single key. That's where SaveableStateRegistry comes into play. we covered SaveableStateHolder that holds all registries. Now let's go in and see what is actually this registry that is being provided here for each of our screens. It is very simple interface. It has consume restored, well, to get the state back, to restore it, to consume it, so it will be removed from the saved states. Registered provider, that it is registering a value provider for the state for a given key, and multiple, as I said, multiple value providers can be given for a single key. Verification, checking if something that we are giving to it can be saved. It will perform save for all providers that are registered here. It will call save, and it will gather all of these any values returned from these value providers registered for a given key, and it will put them in a list. That's why everything is a list, and ordering of things matters. And here we have entry that will just give us the ability to unregister a provider. So we have register provider, and the entry gives us the ability to unregister it when it is no longer needed. And we will see how that works. So we saw the interface, and now let's see the actual implementation of SaveableStateRegistry. SaveableStateRegistry implementation is where the coordination between restoring and saving happens. Again, we have can be saved for checking if the state we are giving to, if we're trying to save, can be saved, and then we have restored. Those are all previously saved states that are being restored. We have value providers. Those are registered value providers and those are waiting the call to save, and then they will be called to provide their own state, delegate to the previously mentioned one. Then we have consume restored for consuming restored state. First, it will restore states, as we said. Multiple can be saved for a given key. That's why it is a list. If the list is empty, there is no saved states. Return null. And this is the interesting part. You will notice this for both consuming and saving. There is a difference when consuming and saving for a list of things, when there are multiple providers or multiple states, and when there are just a single provider or a single state, because ordering matters of both saving and restoring. If there is just one provider that saves null, then it will not be saved because it doesn't exist. If there is a single state for a given key, then it will be returned. But when there are more than one, everything will be saved and everything will be restored, and ordering matters. As you can see, it will restore for the given key, it will take a state, and it will put the rest back into the list. Why? Let's say that we have two value providers that provided two different states that we saved. First provider provided null, and the second one provided string one, and they both provided it for a same key. And when we call restore first time, we expect to get null. If we treat that the same as with a single one, the null will not be saved, and then the first one will get one, and the second one will not get anything. It will crash here. So when there are multiple saved states and multiple providers, ordering matters, and everything is saved. So we are consuming a single state, and we are taking the rest and putting them back into the list of map. The remaining list of states, we're putting it back into the map for this key. Then we have registering of providers. It adds value provider to the top level value providers that we saw, and it returns the entry that we mentioned is used to unregister a given provider. Same. If there are multiple ones, yeah, comment even says it here. If there are multiple providers for the same key, then the one will be unregistered and the rest will be put back into the map of value providers. perform save that will save states provided by the providers for each key. So these here are just checks and setups. What we are interested in is this lambda right here. And as you can see, again, there is a difference between a single provided value, single provider, and multiple providers. When there is a single provider, then the null check will be done and only non-null values will be saved to optimize the solution. And that cannot be done when there are multiple providers, because it needs to maintain order of saving and restoring that we talked about already. So it will save both null and non-null values, but it will check if value can be saved only for non-null ones. Those are registries, and now let's go back and see what this wrapper is. That's what's remaining. So the wrapper, as you can see, it is both the Saveable State Registry and the Saveable State Registry owner, which is a lifecycle owner, and it implements Save State Registry by delegation. So it will just implement the registry that is being created here. And why it needs to be owner and why that does it need to be lifecycle owner, because it has this controller here that is being used to access the registry, and on lifecycle events like start or stop, destroy, it needs to be attached or registered, and it needs to detach or unregister access for this controller. So they have some workarounds here, etc., but we don't care about these in particular. This will be cleaned up. Just you need to understand that it needs to be a lifecycle owner, so it will, for example, when on create lifecycle event happens, it will attach. When there is on stop, typically not on destroy, it's too late for on destroy, but on stop, then it will unregister or detach, and you cannot access add anything more at that point to that registry through this controller. That's it for the SaveableStateHolder. I hope it wasn't too complicated. And now we'll see about ViewModelStoreNavEntryDecorator and how it builds on top of what SaveStateHolderNavEntryDecorator does. It's not nearly as complicated as the previous one. We'll just dive straight into it. Here you see that it is checking that local ViewModel store owner exists, and this can be confusing because we are trying to make our entry ViewModel store owner, and now it is checking for the store owner, and we'll see why. But at this point, local ViewModel store owner will be our enclosing activity, fragment, or platform specific containers on other platforms, iOS, desktop, etc. And it will register, it will define what will happen on pop. So if this returns true, ViewModel will be cleared. If this returns false, ViewModel will not be cleared. And then let's go into the implementation of the decorator. And as you can see, it needs that store owner just to provide store to the decorator. So we have store here and definition on pop. On pop, it will check and remove. On decorate, it will add. But what's important is where it is adding and where it is removing from. It is this entry view model. This is just a provider for it, but here is the implementation. So you can see that it itself is a view model that keeps track of all owners. This is not yet, at this point, this is not yet, let's say, typical of ViewModel store and store owner relationship, but the owners are registered inside of a map, so the owner owns this map. So this any will be our key, our entry, the navigation entry, our screen, and then the ViewModel store will be ViewModel store that is associated to it. And ViewModel store is the foundation of everything. It handles clearing the ViewModel state, etc. But that is other topic. And then that ViewModel store we get it here, and then there is this local saved state registry owner dot current, and if you remember, that is the one that we provided here. So the registry owner that we are getting here will be one that that was provided in a previous step for the previous decorator. That's why it is important to order them properly. And then it will create a child ViewModel store owner. It will implement a store ViewModel store owner. This is just the implementation of it. By delegation, it will implement the registry owner, but what is important here and where the switch happens from the enclosing activity fragment or specific platform container for the ViewModel store owner is here. So it does composition local provider, local ViewModel store owner, which up until this point was the enclosing one, will become the child one created here for our individual specific nav entries, and all of those will be kept here. So they're kept here with the not really typical or conventional ViewModel store and store owner relationship, but they are associated to one another. So key entry owns a store, but it's becoming typical traditional, how you want. However, relationship between the ViewModel store and the store owner here, and that's why when we go here and do local ViewModel store owner dot current, then it will be our enclosing entry, and it will be the same for every other entry. So here the current will be this one. And that's it for this one. We implemented ViewModels, the foundations of ViewModels, and you will most likely use the libraries for these, but they just built on top of what we covered. I hope that you learned something from the deep dive if you stayed to listen. And yeah, see you in the next one when we discuss deep links for navigation 3. See you in the next one.